Welcome to Mr. Benjamin's Math World. Now we are going to be working with multiplication of complex numbers. And we are multiplying these two complex numbers, and like we said before, when the division of complex numbers, this is binomial, and it's a complex number because it is formed by two parts. The first part, the number, which is the real part, and the imaginary part, which contains the letter I, the variable I. And before we start multiplying, because this is a multiplication, as you can see by the use of the parentheses, it's a multiplication. I'm multiplying these two binomials because they both got two terms. It's always good to know and remember basically this one, but this one comes from the information that I is the same as square root of -1. In order to get I to the second power, as we know, we just replace the radical for the power 2. Therefore, I to the second is equals to -1, and this is the piece of information we need to keep in mind because we are going to be using it further. Let's multiply these two binomials. When multiplying binomials, we can also use the FOIL method. Let's use it. First terms, 4 times 2 is 8. Outer terms, the terms outside, outer terms is 2. Let's multiply 4 times positive 3i, which is 12i. And now we multiply the inner terms, the terms inside these two, which is negative 3i times 2. This is negative times positive is negative, and 3i times 2 is 6i. And the last terms, which these two, we are multiplying a negative 3i times positive 3i. We're multiplying the signs. Negative times positive is negative, and 3 times 3 is 9, and I times I is I squared. Square again, because 1 plus 1 is 2. And when multiply variables, equal variables, you add the exponents. The exponents, I'm sorry. Let's solve the like terms, if any. And we do have like terms here. The like terms are 12i and negative 6i. They are like terms because they have the same variable with the same power. So the only two like terms in this expression are these two. 9i to the second, it does not have any like term because there's no other I to the second. And 8 is an independent term. There's no other number by itself in the expression. So I'm going to solve these two, but first I'll bring down the 8. And this is 12i minus 6i is plus 6i. I'm subtracting like terms. 12i minus 6i, 6i. And then I'll bring down the 9i to the second, but here I stop because I know that I have with me this information which tells me that I to the second is the same as -1. So when I brought down the 9, instead of writing I to the second again, I'm going to replace the I to the second for -1. But not like this, because this represents a multiplication. Because 9i to the second means 9 times I to the second. So I cannot leave it like this, because if I leave it like this, I'm not multiplying them. What do? Then I'll have to use parentheses. And this parenthesis tells me that I'm multiplying the 9 with the -1. And then I proceed. Again, I'll bring down the 8, bring down the plus 6i, because there's no other I up. And then I solve this. It says -9 times -1. Negative times negative is positive, and 9 times 1 is 9. Do I have any other like terms? I do. These two. 8 and 9. So this is 8 plus 9 is 17. And then bring down the positive 6i. And this is the result of the multiplication of this 4 minus 3i times 2 plus 3i. The result will be 17 plus 6i. And this is the way you solve multiplication of complex numbers. If this video was useful, just subscribe and activate the bell in order to receive further notifications. See you next time.